Okay, so for this video, we're going to talk about solving rational equations. So I guess where I want to open this lesson with is, when do you know that you need to solve versus simplify? Well, you solve when there is an equal sign. And so when there's an equal sign in the problem, that means there's going to be a solution. If there's no equal sign, then you're not going to have a solution. You are simplifying. Okay, so for instance, this equation here, it's an equation, right, because it has an equal sign. And I'm just going to jump right into how do you actually solve a rational equation. So first things first, you want to find the LCD of all of the different fractions that you're looking at. And so if we look, so I've got 2 over x minus 1, 1 over x plus 4, 4 over x plus 4. So I can see that my LCD is x minus 1, x plus 4. So I assume that you're already, pretty good with that if you're watching this video. If not, I would suggest going back and reviewing how to find an LCD. The second step is to multiply every term or part of the equation by the LCD that you found. So in this case, let me just show you what that looks like. So here's my LCD. I'm going to show you what it looks like to multiply against each one of these parts. So I actually got to just explode this out into 2 lines because I'm running out of space. But okay, so here's my LCD times the first, LCD times the second, and then I've got the equals, and then here's the last part of that equation. Okay, so what do you think you do from here? Well, the purpose of the LCD in this case is to clear out denominators. So let's go ahead and make some cancellations. So starting with this first fraction here, so I have these x minus 1s are going to drop out. So what am I left with? I'm left with 2 times x plus 4. Next, I've got these x plus 4s, so those are going to drop out. So what am I left with? I'm left with x plus 1 times 1. So I'll just write x minus 1. I think I said plus 1. And then finally, so these x plus 4s will drop out. So what am I left with? 4 times x minus 1. And so now this is what I'm left with. And I would much rather solve this than where we started. So the whole purpose of the LCD is to actually make this a much simpler problem to deal with. And so let's just keep going forward with this now. So at this point I would distribute, and okay, so here I am distributing. Now I need to collect any like terms. So this will be 3x plus 7 equals 4x minus 4. And so now I need to get all of my letters to one side, numbers to the other. So let's see, I'll go ahead and I'll subtract off the 4x. I'll subtract off the 7. So let's see. So what does that give me? I'm running out of space, but okay, so I've got negative x equals negative 11. So that means then that x equals 11. And so that would be our solution in this case, and there's no issues with that. And I bring up the idea of there being an issue with this because there is a thing you have to watch out for. So you have to watch out for solutions that make a 0 in the denominator. So every time you do these problems, there's always this last step of checking for that. So I think it would be best just to show you what couldn't happen. So for instance, let's say I have this equation here. We're not going to solve it. All I want to know is which solutions would not work for this. So you're literally looking for the solutions that are going to create a 0 in the denominator, because a 0 in the denominator, in plain speak, it's a no-no. That's the problem. So for this one, I literally just think, what could I plug into the denominator to make it 0? And if you are looking at that and you're like, I have no idea, we'll just set it equal to 0 and then solve. So for this one, x equals negative 1 would give me a 0. For this one, x equals negative 3 would give me a 0. And then for this one, x equals negative 7 would give me a 0. So in this case, there are 3 values that we could not have as a solution. So if we got these as a solution, we would have to throw them out. That's the idea. Okay, so I'll ask you that again. What solutions would not work in this case? Maybe you want to pause the video for a second to think about it and hit play when you think you've got it. Okay, so in this case, this factors to x plus 3, x minus 3. So really, there's only 2 solutions that aren't going to work. X equals 3 and x equals negative 3. If you got either one of these solutions, then that would cause a 0 in the denominator, so you would discard it. Okay, so with that in mind, let's keep going with a few more examples now. So I think this is actually a pretty simple version of this because we can tell just by looking at this that the LCD is x. So what I want you to do is I want you to pause the video and try this one totally on your own just to make sure you've kind of got the basic idea down. Hit play when you're ready or when you're stuck. Okay, so the first thing I'm going to show you is I'm going to multiply this LCD-x by every part of the problem. And so if you remember from complex fractions or from other things that we've talked about, so I don't mean just multiply by the fractions, every single part. So this 1 here has to also get multiplied by x. A really quick check for yourself on this is if I have 1, 2, 3 parts of the equation, then I should be multiplying that LCD by that many times, so 3 times. Okay, now in this case, once I multiply by the LCD, everything becomes easy peasy because these x's drop out and these x's drop out. So then I'm just left with the equation x minus 8 equals 10. And so from here, I can just go ahead and add the 8 to each side to get x equals 18. So that's the spirit of what we're trying to do. And so now let's just increase the level of complexity. Okay, so I have another example here now. So I've got 5 over x minus 3 minus 2 over x squared minus 9 equals 5x plus 13 over x squared minus 9. So I want to challenge you to try this one totally on your own. And the worst that happens, right, is that you get it wrong. But you're more likely to understand this and retain this and do well on your homework with this if you try it on your own. So pause here, hit play when you're ready. Okay, so first things first, the LCD in this case is going to be x plus 3, x minus 3, which is the same as x squared minus 9. I just wrote it there, so just for my reference. Okay, so what I need to do then is I need to go through and I need to multiply every single part of this equation by that x plus 3, x minus 3. And you'll notice that I actually kind of flipped forms as I thought it would work for me. In that, okay, so here I kept it as x plus 3, x minus 3 so that I could see what to cancel out. But since I know that this is equivalent to x squared minus 9, when I got to this fraction, I just wrote it as x squared minus 9. Okay, so let's just take a look at what we would cancel. So in this case, the x minus 3's cancel. Here the x squared minus 9's cancel, and then here also the x squared minus 9 cancel. Okay, so one thing that can make your life easier is you can actually, like, as you get used to doing this, you're probably going to start seeing like what should cancel out. So if, let's see, maybe I could maybe I could go back a second. So if I were to come back to this point here, so just when I think about multiplying this by this, you probably are getting pretty good at this in that you know now what cancels out. So I know that the x minus 3 is going to cancel out. So you could actually just jump to then 5 times the x plus 3. And then like for this, I know that the whole denominator is going to cancel out. Same thing here. So if you're starting to see that, you can actually just state what the LCD is and then make that jump. Or if you're like, no, I'm a visual person, no problem. You can always do all of this work. But either way, you can always like jump to this step, I guess is what I'm saying. Okay, and so from here, we should be able to solve this. So I'm going to distribute the 5. Let me change my pen color. 5x plus 15 minus 2 equals 5x plus 13. Okay, and so now I'm going to rewrite this as 5x plus 13 equals 5x plus 13. And so what do you notice at this point? Well, this is now going back to some older algebra. This is a thing that can happen. So the thing that I noticed with this is, so if I were in computer mode and didn't realize that both sides said the same thing, I could technically just subtract everything over to one side, and what I would ultimately get is 0 equals 0. So it doesn't matter which one of these you want to use. This and this literally mean the same thing. So when both sides are equal, how do we interpret that result? That result means all real numbers are solutions, which sometimes gets represented as negative infinity to infinity. So this is just a little bit of a review, and this is a thing that could always happen, and so it happened here. So all real numbers are solutions, except, so actually I probably shouldn't write this. I shouldn't say that because that's technically not right, sorry. Okay, there are two numbers that would not work. So what would be the two numbers that wouldn't work in this? it would be -3 and +3. So any numbers except for -3 and +3 would work. So otherwise everything else is good. So you just can't get that 0 in the denominator. Okay, so let's take a look at another one now. So I've got x squared over 2 equals x squared minus 6x over 3. So this type of problem is actually kind of special because the thing that we notice about this is that I have one fraction on one side and one fraction on the other side. So when that happens, that's what's known as a proportion. And so when you have a proportion, you actually can use a shortcut. You can cross multiply. You don't actually need an LCD. So cross multiply literally means I'm going to multiply this way and this way. So the way that this problem is going to look is that it's going to be 3x squared equals 2 times x squared minus 6x. So here's what I've got now. And let me change my pen color again. I keep doing that. Okay, so I've got 3x squared equals 2x squared minus 12x. Okay, so now that I see that I have squared terms, so in general, when you have squared terms, that means usually that you're going to have to factor. So when you have squared terms, you're going to want to bring everything over to one side. So I'm going to go ahead and bring these over to this side. So let's see, what is this going to become? This will become x squared plus 12x equals 0. And so then what I can do is I can now factor out x. So this becomes x times x plus 12 equals 0. And so now that I have this factored, what I need to do now is I set each solution equal to 0, and those are my two solutions. So x equals 0 and I set each factor equal to 0 like this. And so what that means is my two solutions will be x equals 0 and x equals -12. And I got that from setting each factor equal to 0. So that's just what you do when you have factored terms, or when your equation ends up with factored terms. Okay, so we have one more. So for this one, I want to encourage you to try to see this one all the way through on your own. So why don't you pause the video, give it a go, hit play when you're ready. Okay, so in this case, my LCD is x plus 1 times x minus 1. And so I want to now just try to do this without having to write out all of the work, because I know it gets kind of tedious. So if I multiply this by the LCD, what will drop out? Well, I know in my head, these are going to drop out. So what am I really going to be left with? 4 times x minus 1. So you can like visually inspect this if you feel comfortable with that. So let's keep doing that. So what about this 10 over x squared minus 1? Now what's going to drop out? The entire denominator will drop out, so I'm just left with 10. And then this last part, now my x minus 1s are going to drop out, so I'm left with this x plus 1. So now we'll distribute. So this is 4x minus 4 equals 10 minus 5x minus 5. And if I collect my like terms, so I get now 5 minus 5x on this side. So now I need to bring the x's to one side. So I'll bring 5x over, and I'll bring the 4 over to the other side. So let's see, I'm running out of space here, but I get 9x equals 9. And so if I divide both sides by 9, I get x equals 1. Okay, and so now if I check this, womp womp, right, this will make a 0 in the denominator. So we discard that, and the solution is actually nothing, so we can just make this sign here, which is the empty set. Okay, so this video was just kind of intended to give you some of the highlights. If you're looking for slower paced instruction or more examples, check out my video library because I've got more, so you can kind of make this work for you. If you found this helpful, consider hitting the like button or subscribing to the channel. And thanks, guys. I will talk to you in another video.